Hey guys, my name is CBC, and today we're going to be doing derivatives worksheet number 2. So if you want to do it alongside of me, there's a copy of the worksheet and answers in the description of the video, so you can just do those if you want. This is basically an overhaul of derivatives review, so we're going to be talking about the product rule, the chain rule, the quotient rule, and the power rule. And if you don't know what any of these are, we also have videos on each of them, so go watch those individually before if you don't know what I'm talking about. Other things, we're just going to be taking the derivatives and not simplifying because this is a video on derivatives. And then also I'm going to try and indicate when I'm using the chain rule by either circling or underlining. Yeah, we'll see. So let's get started. Okay, so for our first one, sorry, that's my hand. We're going to circle what makes it the chain rule. So we have the inside function of 1 minus x squared. And this isn't the power rule. This is the a to the x rule because we have a number to the x. So the derivative of a to the x is ln of a. So what we're first going to do is the chain rule. So we say the derivative of the first one, a to the x, so that's 10 minus x squared. And then the derivative of a to the x is ln x. So then we're going to multiply by ln of 10, or ln of x, and then times negative 2x, which is the derivative of the inside function. Okay, so for the second one, I underlined what makes it the chain rule, which is the k tan to the root x. And then also root x is the third function in there. So there are 3 parts of it that we have to do. But remember, k looks confusing, but it's just a number, so it like represents a constant. And the first thing we're going to do is rewrite root x as x to the 1/2, just to make it easier for us to figure that out. So that's what I'm doing here. And then next we're going to take the derivative. So we do the chain rule twice. So first we do the chain rule of e to the x, so we just rewrite all of that over e. And then we do the chain rule of secant squared x. And then the inside, we do the power rule. So we bring the 1/2 x down and subtract it from 1 on the top. Okay, so for the third one, you always want to rewrite when your exponents are in trig. So we would rewrite this all to this all square, the whole thing. And again, we have 3 functions for the chain rule. So first we have the inside is tan 3 theta, and then the other inside is just 3 theta. So the first derivative is x squared. So we'll do that. Everything inside the 2x is just the power rule. So you bring down the 2 and then do the inside. And then the next function is tan. So the derivative of tan is secant squared of x. And then the inside chain rule is 3. Okay, so next, 4 is super similar. So we want to rewrite, sorry, let me adjust my screen. So we want to rewrite everything as squared. So we're putting that all under the function of squared. And then we do the power rule. So you'd bring the 2 down to the front, rewrite the whole inner function, and then do the derivative of the inner function. And the derivative of cotan is negative CSC squared x. So you write that. And then you also multiply it by the inside of that, and the derivative of sine is cosine of x. So it's important that you memorize these trig derivatives, just so you can know them from when you do this. Yeah. Okay, so 5 looks hard, but it's not that hard. We just have 3 sine functions, basically. Oh god. Okay, so I underlined the first inner function, and then we also have the second inner function. So there's just 3 functions, and it's just the chain rule. So the derivative of sine is cosine, so we're just going to do the outside derivative, and then also including the x, and then we multiply by another derivative of sine, because we still have the inner, leaving the x, and then we multiply by the last derivative of sine, which is cosine. Okay, so for 6, we're going to rewrite the root of x always as x to the 1/2. So I will do that. So yeah, so we rewrite it as x to the 1/2. And then we're going to do the chain rule. And this is inverse tan. It's not tan to the -1. So the derivative of inverse tan is always 1 over 1 plus x squared. So our x is x to the 1/2. And then we multiply by the derivative of x to the 1/2 using chain rule. Okay, so for 7, we're going to rewrite it again after I move my paper up. So we're going to rewrite that as, this is basically the same as 6, but the inside and the outside are switched, if that makes sense. But yeah, so we'll rewrite that as tan to inverse tan to the 1/2. And then we just have the inside function, so that makes it the chain rule. And then we'll do the power rule, so bring 1/2 down to the front. And then do the inner function, which is inverse tan. And then do the exponent. And then we will write the derivative of inverse tan. Nice. Okay, so number 8. This is the chain rule. You can see because we have the inside function of 2x plus 1. So first we're just going to do the derivative of the outside. So the derivative of inverse sine is 1 over root 1 minus x squared. Sorry, 1 minus x squared. And our x here is 2x plus 1. So then we'll do the derivative of 2x plus 1, which is 2. That's all you have to do. So 9, this is our first product rule. You can see because there are 2 things being multiplied by each other. So basically what you do is you see the first function is secant x squared, and the second function is cosine of x. So you're going to take the first function. Yeah, it's product rule established. So you keep the first function the same, so you write secant of x squared, and you'll notice I underline x squared because that'll make it a chain rule in the end, and then you multiply by the derivative of the second function, which is negative sine of x, and then you add the second function times the derivative of the first function. Yep. And the derivative of the first of tan x, you're just going to multiply that by the same. Sorry if you can't see it. I think I'm going to rewrite it. 1 second. So I rewrote the question, but you can just basically see you keep the same, and then you multiply by the derivative of the second, and then you add the same function of the second, and then multiply by the derivative of the first. And the first also has a chain rule, so you have to account for the x squared in the parentheses. So that's the answer. Okay, for 10, Arc sine is just inverse sine, so it's sine to the -1, and then underline the tan theta because that's an inside function. So this one's similar to number 8. And just remember the derivative of tan is secant x squared. Secant squared x. Yep. Okay, so now we're on the back page. So for 11, the n function is x squared plus 10. This is an ln of x problem, which is super common. So just be familiar with the derivative of ln of x, which is 1 over x. Sorry if you can't really see this one second. Okay. Oh gosh. So it's the derivative is 1 over x, and then you just multiply by the derivative of the inside function, which is x squared, which is 2x, sorry, because the derivative of x squared is 2x. Okay, and then for 12, this is basically the same. Remember, the derivative is 1 over x, so your x here is cotan, and then you multiply by the derivative of the x. So the derivative of cotan is negative CSC squared theta. So for 13, this is the same, but the ln of x is inside the function. So you use the chain rule. So our inside is ln of x. And then just remember the derivative of cosine is negative sine. So we're going to write cosine of ln of x times just kidding, I messed up. You write the derivative of cosine, which is sine of ln of x, and then you do the derivative of the inside function, which is 1 over x. Okay, 14. This question isn't usually asked, but it's a log base a rule. So the derivative of log base a is always 1 over ln a times x. So you're going to write 1 over ln of the a is 2 here. And then you multiply it by the thing in the parentheses, which is 1 minus 3x, and then you do the derivative of the thing in the parentheses, which is negative 3. Okay, so 15 is the product rule. And you can switch around the product rule whichever way makes it easier. So do like the first half of the function or the second half of the function or whatever you want to do. So we're just going to do the second half. So the derivative of sine of x is cosine of x, and then you multiply by the second half, which is ln of 5x. And then the derivative of ln of 5x is 5 something. Oh, sorry, is 1 over 5x, my bad. And then you multiply by the derivative of 5x, which is 5, and then you write sine x. Sorry if that was confusing. So 16 is our only quotient rule question. The rhyme to remember is low d high minus high d low over low low. So just going through it, we write our low, which is 1 minus ln t, times the derivative of the high, which is 1 over t, minus high, so that's 1 plus ln of t, minus or times the derivative of the lower t, which is negative 1 over t, and then low low, you just do 1 minus ln t squared. Perfect. Okay, so next we have 17. I think you can see that. Sorry if you can't. Okay, so 17 is a product rule within the chain rule. So first we want to write our sine squared x as sine x squared, just because that always makes things easier. And why wouldn't you want to make it easier? And then you do the product rule. So now we're going to do it. Watch this. So now we take the derivative. So that's our inside function. And then our other inside function is sine x. And it's all squared. Sorry. So let's do the product rule. So this one's kind of long, but we start off. So we start off with the derivative of ln of x. So we're rewriting our x is x to the fourth times sine x all squared. So we rewrote that, and then we're multiplying it by the derivative of that. So it's the product rule inside of that. Hopefully you can see the end. Let's see. Good. Sorry. Yeah, so that's our product rule. Okay, so for 18, our inside function is e to the x. So we're going to have a chain rule. So you rewrite the number, and then you take the derivative. So you just kind of see 4 on the top. But if you did work this out with product rule, you'd figure out that you can't multiply 4 because it just turns into 0. But a lot of people do that and then just see that they made that mistake because it works out. But anyway, so e to the x is our inside function. And just on this one, remember that the derivative of inverse secant is 1 over x root x squared minus 1. So just keep that in mind. Okay, so for 19, our inside function is e to the negative x. And you can see on both of these, don't forget the negative x, because that's not just a negative, that's like an inside function. So this one is product rule. You can switch it around, but you don't have to. So first we do chain rule. And the derivative of e to the negative x is e to the negative x times negative 1, so don't forget that. And then for the second half of the problem, we do the product rule. So that's the answer. So for 20, we have 3 functions again. So our inside function is ln of 1 plus e to the x, and then our third inside function is 1 plus e to the x. So first we are going to do the power rule. So bring down the 2, rewrite your inside function, and then do to the exponent of just 1. And then multiply it by the derivative of the inside, which is ln. So our derivative of ln is 1 over x. So then rewrite the inside function and then multiply by the derivative of the inside function. Okay, so last one. So we have 3 functions again. This isn't the power rule though, it's the a to the x rule. So we have the inside function of CSC 2x and then also 2x. So we rewrite that as the a to the x rule. Our a is 8, sorry. And then just don't forget the derivative of CSC is negative CSC times cotan. So remember your trig function derivatives. And don't forget that the 2x goes in both slots, but then at the end, I'm not done. Then at the end, only multiply by 1, 2, not 2 2's, because you're only taking the derivative of 1, 2x. Okay, good job, guys. That was awesome. So if you want to see more videos like these or get more practice like this, we have other review videos that you can check out. Other derivative review videos and other videos. So look at those. Also, like our page or subscribe to the page. And yeah, let other people know about us because this is a really cool opportunity to learn more calculus and get better. All right. Thank you for watching and enjoy. Bye.